This helps us provide the highest quality webinar for all who are attending. In today's webinar, we're going to review some of the problems associated with traditional work-holding systems. Then, we'll share several examples and options of quick, versatile, and highly accurate fixture solutions. What you'll learn in today's webinar will be applicable to everyone, whether you work on vertical, horizontal, 3-axis, or multi-axis work centers. We're honored to have John Zaya from Big Kaiser presenting our webinar today. John is the Work-Holding Product Manager at Big Kaiser Precision Tooling in Hoffman Estates, Illinois. He's been with Big Kaiser since graduating from Michigan Technological University in 2006. If you'd like to ask a question, please use the chat box function on the GoToMeeting screen and be sure to send to all. John will receive these questions during the webinar and address them all at the end. So without further delay, John Zaya on multi-axis quick change work holding systems. John, thanks in advance for educating us.
Thank you, Mike. It's my pleasure being here. I also would like to say thank you to all the attendees. Thank you for your time. Again, if there's any questions, please throw them in the chat window or send them in at any time. My contact information is there. Please feel free to call or email at your convenience. Thank you. Also, just a side note, I'll be calling out slide changes, so disregard those if you would. As Mike discussed, next slide, please. As Mike already mentioned, the purpose of this webinar is to discuss the issues that occur when you're looking at fixturing on 5-axis machines. Many times the fixturing for a 3-axis machine, vertical or horizontal, tends to be cumbersome when trying to be used in a 5-axis application. So we'll be taking a close look at how this fixturing system that we offer here at Big Kaiser, as well as other options from other manufacturers, can help solve some of the solutions, solve some of the problems that occur when you start looking at 5-axis machining. Next slide, please. So to start off, I kind of always like to do a quick review. That way everybody understands kind of the differences between 5-axis machining versus 5-sided machining. 5-axis machining generally creates a complex surface that's generated as well as the cutting tool in multiple axes, as well as rotational axes, along with the 3 traditional linear axes. Here are a couple examples of some of the common 5-axis work pieces that we see often: impellers, joints and dental implants, molds, and quite a few aerospace component parts are manufactured on multi-axis machines. One of the key requirements for 5-axis machining is CAD/CAM program. These surfaces are generally so complex that a person cannot manually generate the coding required to generate the movement that's needed. So you always end up having to have some sort of a CAD/CAM program. There are various different machine types. There's vertical machining centers that are augmented with trunnions and indexers. There's horizontal machines that have a little bit of 4 or 5-axis capability. But in general, many of these applications still apply no matter the machine type itself. Next slide, please. The other side of this is what I call 5-sided machining. These are generally examples of parts that, although there are multiple faces, the geometry that's created is very simple. Pockets, holes, threads, things like that. And accessing these faces are the challenge, not necessarily the geometry itself. This is often called 3+2 machining because it requires the same linear positions, but then second or 2 angular positions. But what's also very nice about this type of machining is that oftentimes you don't have to have a CAD or CAM program in order to generate it. It's all positional movements and angular movements that As long as you have a good print and a good set of tools, you can generate the features that are needed. Next slide, please. So here we have kind of a good side-by-side comparison of 5-axis machining and 5-sided machining. Oftentimes you'll see examples of impellers, but the surfaces could be various types, but it all requires multiple movement of workpiece, cutter in sequence with one another to generate that surface. 5-sided machining, such as this example, is pretty straightforward. The workpiece is rotated around and the z-axis of the machine moves linearly to generate the features that's needed. So as you can see in the example, the workpiece is held with a very traditional style of fixturing, and we'll get into that now. Next slide, please. So some of the traditional systems that are out there that have been around for very long are vices, toe clamps, 1, 2, 3 blocks, V blocks, risers. These types of clamping components have been around for as long as machining has been around. They're very ubiquitous. You can find them in almost any type of facility. Any type of manufacturer is going to have a lot of these types of components. Some of their key benefits: they're flexible, they're very inexpensive, they can be reconfigured almost instantaneously once a problem is determined. It doesn't require any kind of a CAD/CAM program at all to use them. But they do have some drawbacks and some issues, primarily interference, accessibility, and with considerations of production, we're wasting a lot of time sometimes getting these components set up. So we'll go to the next slide. We'll see how traditional strap clamps or toe clamps can be used in a 5-axis work envelope. This mold base is being held down by 4 fairly simple, straightforward clamps. And now this is where we get into some of the limitations of these items. This part is not being located in any way by the clamps. It's just being held in place, but we are losing accessibility to the edges of the workpiece. So although this part can rotate as freely as the machine allows, we don't have the ability to do any work to the workpiece on its outside edges. Next slide, please. Vices are also very common within many manufacturing facilities, and a lot of customers like to reuse their vices for 5-axis or 5-sided machining. This workpiece is a pretty simple, straightforward 5-sided machining workpiece, but the problem comes when that vise and that rotary turn 180 degrees, the tail end of the vise could interfere with the spindle housing. So even though vices have their place, sometimes their physical size and bulkiness can become a problem. Next slide, please. Another type of common element that we see in 5-axis machining and 5-sided machining are risers. And these come in a wide variety. Oftentimes they're homemade out of necessity. A customer who might be new to 5-axis all of a sudden may find that their previous system may not work because it doesn't provide enough elevation to the workpiece, which will be a key factor as we go forward. Risers, depending upon the type of material that's being cut, may not be able to withstand the cutting loads and the force loads from the cutting action. So here, for example, this is a pretty simple wood component that's being held by what I would consider fairly simple and maybe lightweight risers. But that's fine because it's a wood application. It's not cutting a heavy steel workpiece or a complex aerospace component that needs to be very rigidly held. So for certain applications, some risers are perfectly acceptable, but in some they're not. Next slide, please. So we're going to look at some of the new systems that are out there. We'll start off with the vices. There are there are plenty of different options for vices specific for 4, 5-axis, and 5-sided machining. I kind of lump these into what I call tall jaw options. Generally, they achieve that height that we need by having a taller jaw than a base or bed plate. We can see here in these two examples, the jaws are a little bit taller than we're used to, but they allow for the elevation that's needed. But as we see in the warning diagram at the bottom, the clamping element or the clamping force needs to be applied closer to the workpiece than most vices allow. That's to prevent the workpiece from being squeezed out of the jaws due to the jaws tilting and allowing the workpiece to move out. Next slide, please. The other type of mechanism that's applied oftentimes are dovetail style clamps. We see two examples from two separate manufacturers here. One is more of a square type vise from 5th Axis, and then on the right we have a natural dovetail modular system that's offered from Raptor Workholding. Both of these have the same kind of technology built into them in that the workpiece is being held by about 3 millimeters or 1/8 of an inch of material at the bottom of the workpiece that has been cut with a special profile to interlace with the faces of the vise. This holds the workpiece very securely, and it provides that same elevation element that's required for 5-axis machining. These types of items are also becoming more and more prevalent in even traditional machining applications because they work so well in 5-axis. Next slide, please. One of the things that we here at Big Kaiser have figured out to do is make a system that is a combination of almost all of these. It provides us a dovetail clamp if we need it. It's modular in that the component assemblies can be moved around to accommodate a variety of different workpieces. The elevation is there as well, so we are moving the workpiece up off of the table. And we also have the clamping element very close to the workpiece to help minimize any type of squeeze out of the part. Some other manufacturers also have these same features, but we also have them also. Next slide, please. If you recall from our traditional section, we had also talked about risers and their capability of providing higher elevations. That generally is needed for larger workpieces that have a very large footprint. Here we see examples of how modular risers can be used in order to provide larger fixtures and larger parts that same structural stability that they need, whether they're in a 5-axis or a 3-axis +2 application. So they can still do all the capability that's needed. Next slide, please. So if we're keeping in our minds the capability of needing height elevation for 3-axis workpieces, height elevation for 5-axis, as well as 3+2 5-sided machining, the system that we offer from Unilock from Big Kaiser combines all of those capabilities into play. We have within our system the ability to provide elevation. We can accommodate various different heights. If, for example, we see in the upper right-hand corner, our workpiece has 3 different elevations to it. We can get in and around those to provide the height that's needed to avoid interfering with those. We are also extremely still very robust as some of the traditional systems are. You can see we can handle very large parts, and the system is still just as flexible as anything that's needed. Next slide, please. One of the other key factors of our system is that it allows you to handle very large, very cumbersome workpieces. here we see this workpiece is in the 40 to 45 ton weight, and we're holding it with essentially 4 components. Next slide, please. So the process that a lot of the new systems out there incorporate is basically a 3-step process. First operation preps the workpiece and you install a clamping element. Here we see our unilock knobs clamped to the underside of the workpiece. That then goes into the machining center and is held by the base clamping units. And this can be very similar to our system or to other manufacturers. And then that allows you access to all of the 5 faces that are accessible to the perimeter as well as to the top. And then in the final process, you'll see that the workpiece has now been essentially entirely machined with 1 holding, and then final machining operations would be to remove the holes that were needed to mount the clamping elements or the knobs. And this would be true for a lot of the other systems out there. The capability of having your clamping elements being used in process is very key when it comes to 5-axis machining. Oftentimes you're not dealing with a entirely raw workpiece. You may have a part that's been partially processed and then needs to be held by another subsequent fixture in order to remove the raw material or rest stock that was on the underside. Next slide, please. Also within the new capabilities of 5-axis machining are multi-part holding systems. And these multi-part holding systems allow you to turn what a lot of people think of as a one-at-a-time part machine. Some 5-axis machines, depending on the part, can only hold on to 1 workpiece. But when you start looking at smaller parts, you need to think about increasing your production capacity, and that's generally done by having more workpieces in the machine that it can then produce. So here we see an example of how we have a 4-stud or 4-position work holding system that's holding onto 4 components at one time. The machines, 5-axis machines, have the flexibility to reach all of the faces because they have the capability of putting the workpiece at any angle that's needed in order to access it. These systems come into play a lot more in the smaller workpiece envelopes, anything generally below 3 to 4 inches. Once you get larger to that, then the machines generally have more and more problematic access issues. So when you're dealing with smaller medical components, smaller aerospace components, we're seeing a lot more customers using this type of system in order to have that higher production capacity that their 5-axis machines are supposed to have. Next slide, please. This is a good example of how a larger machine now has that multi-part access with a larger workpiece. These parts are about 4 to 5 inches long, but the fixture has been designed to allow for access to multiple faces on multiple workpieces. So they're gaining exponential production capacity just by having multiple parts inside of their fixture. This capability sometimes requires basically a custom fixture to be designed, but that's not to say that that entire fixture itself could not be modular with a 0-point system underneath it, allowing that entire fixture to be replaced much quickly when it's needed. The other side of this, everything we've looked at so far has either been a retrofit to the machine done by the customer themselves, but a lot more machine builders are coming online with the concept of having palletization capability. Next slide, please. In the 3-axis world or 4-axis world on horizontals, fixturing, racking, and pallet systems have been around for quite a while. As you can see with the example on the far left there. There are quite a few manufacturers of machines as well as aftermarket OEM systems or aftermarket systems that can be integrated with machines to make pallets interchangeable and move from machine to machine as needed. This is also now becoming more and more prevalent in the 5-axis realm as well. More machine builders are building machines that have pallet systems, and there are also a few aftermarket companies that now have the same capability. And here we see 2 examples of how 5-axis applications are being held on those pallet systems, whether it's with the dovetail style vise or a multi-part fixture system. These capabilities are there to help make machines even now more production capable by increasing that production capacity as we've discussed earlier. Next slide, please. One of the more interesting advances that I've seen recently that I just kind of wanted to briefly touch on is the ability to index a workpiece directly on the face of a tombstone. So here we see an example of a product that's manufactured by a company called KME, and they have the ability to index each of those round units on each face of the indexer. So even in this application, even though it's a traditional 4-axis machine, it's gained that capability of 5-sided machining by having the workpiece be able to rotate independently and not require a secondary fixture or secondary operations. So the capability of multi-axis systems to incorporate fixturing is there if somebody really does their research and finds something like this. Next slide, please. So one of the next level from the system, or most systems, is to automate the system using a robot to load and unload fixtures. This also can be true of 5-axis machines. Fixturing systems can be built to accommodate the access that's required, but still have the capability of being loaded and unloaded to a racking system, as we see here. Automation systems in 5-axis machines are still somewhat in their infancy, but they are gaining popularity as more and more companies are gaining popularity with the 5-axis machines. They still want that capability of automation as they have on their traditional machining centers. I also wanted to take a quick moment to point out that next month, FANUC will be doing a presentation also through NTMA, touching base on automation systems. So if you're looking to see and understand a little bit more on that, please tune in next month. Next slide, please. And that basically brings us to the end of our presentation. Thank you for your time. If there's any questions, I will be available.
Great. Thank you, John. Hey, if you have questions on anything that you saw or you would like to ask John, please just type that in the chat box, and we will we'll get those answered. So, John, at one point you were talking about the 0-point, I think you called them knobs, in your presentation. What kind of accuracy can we expect from that 0-point system? Is it really 0? Perfect?
No, unfortunately, there's no such thing as a perfect locator or location. Our system provides 1 to 2/10 location repeatability. I very rarely have come across a customer whose workpiece has a 0 location tolerancing system. It just doesn't exist, unfortunately. But most systems out there are in that range, 1 to 2/10, maybe 5 at the most, because most of it's being used on machining applications where if you have a very tight workpiece, having a very open tolerance work holding system would not work, because now you're building a stack of your tolerancing based from the table of the machine through the work holding system and then through the part itself. And that in many cases would cause the part to be out of specs.
Well, 1 to 2/10 is pretty darn good. Pretty darn good. And what's the entry cost point for someone that's considering 0-point systems like you described?
So if we're looking at, say, for example, the knobs, our knobs are generally about $100, and you would need, depending on the quantity of chucks, you would need a commensurate number of knobs per fixture. At minimum, generally, so if we're looking at, say, like a smaller fixture, handheld size, you'd be using 1 knob and then a small timing pin. Once you start getting into something that's got some length to it, say about 10 to 16 inches of length, now you're going to need a second chuck in order to provide that additional retention mode, and that's where you're going to gain that additional knob. Now, that additional knob can't have the same location accuracy as the original, because now you would have 2 knobs fighting each other for locational accuracy. So that second knob is actually what we call a B knob. And this is very similar to a diamond pin and round pin situation. That diamond pin or diamond knob has been relieved and only makes contact at 2 points in order to allow for the freedom to control the angular accuracy, but not adjust or interfere with the locational accuracy of the original A knob.
Okay, thanks. That makes sense. Does the machine size affect the fixture options that a person would be considering?
Yes. In many cases, one of the things that we see very much when customers are moving from 3-axis machines to 5-axis is that they kind of stay in the same mindset of, I'll buy a machine that's bigger than my smallest workpiece, or bigger than my biggest workpiece, I should say, and then that way I always have enough capacity to handle smallest to biggest. Well, in the 5-axis world, that can lead to some problems, primarily on fixturing, because what will happen is if your table, let's say, for example, is 160 millimeters in diameter and your workpieces are 200, then that means you've gotten a table that's too small. So a lot of manufacturers have tables that are in the 210 to 220 size in order to account for the fixturing. That would be generally in the 190 to 200 millimeter size, and then your workpiece envelope matches that as well. We've also seen, unfortunately, some customers go too big on their machine tables, and they'll get a 400 or 500 millimeter diameter table back to that 150 to 200 millimeter workpiece. And so then what will happen is they have to elevate the workpiece high enough off the table in order to clear the housing of the spindle. As we saw very early on, the housing of the spindle can be fairly large in diameter or square depending on its formation. And so that has to be cleared from the table. So you've got to elevate the workpiece, or what we also see, again, because we are a tooling company, is we will see customers that go with a very long tool in order to reach all the way across the dead space of their table.
And that's kind of introducing rigidity or perhaps surface finish issues in exchange for that. Okay.
It's, with tooling, once you get over a longer length, it's very hard to build it more robustly so that it eliminates chatter and vibration. It's easy to build a very large fixture underneath a workpiece, to elevate it and maintain that rigidity that it needs, much more so than it is to do anything on the tooling. Because the tooling is a rotating mass, it has to deal with the dynamic situation that it encompasses, or that it sees when it's rotating over a much longer length. So that is much harder. Although we have dampened systems that can help, they eventually reach a plateau effect. And they're also much more expensive than it is to build a much more rigid fixture underneath the workpiece that elevates it.
Hey, much like you described machine size affecting fixture options, what about machine types? Vertical machining centers, with an aftermarket trunnion versus, a gantry style or a traditional trunnion style. How do those affect the fixture options that a person would be selecting?
Sure. So if we look at, say, a vertical machining center that has an aftermarket trunnion or even an actual full trunnion style machine, the fixture, the table itself provides you kind of a good footprint for the fixture to be mounted to. Now, one of the key issues with that is the mass that's related to the fixturing, the mass of the workpiece. When that trunnion style table moves and rotates, it now has momentum that the machine has to resist in order to position it correctly. So that means the fixturing underneath it can't be extremely heavy. It can't be just a solid block of material that adds all this additional weight and mass. However, when we look at, say, like a gantry style 5-axis machine where the workpiece is stationary and the gantry and the head encircle and move around the workpiece, that could be a solid block of steel and the machine would know no difference, because everything that's moving is part of the machine that is not part of the momentum of the workpiece. So when we're looking at a gantry style machine versus a trunnion style machine, we generally try to make the system as big as possible to encompass as much surface area of the table and as much surface area of the workpiece and fixture as well. But when we go to a trunnion machine, we have to be a little bit more efficient and maybe end up using 3 or 4 clamping elements or units versus half a dozen if the surface allows it. So those are kind of the two systems that situations that we look at, is whether the part is moving or the machine is moving around it.
Okay. What about options for people that want to use hydraulic clamps with 5-axis machines? Is that a possibility?
In some cases, yes. In traditional systems, when we look at horizontal machines where a part or a fixture is dedicated and never comes off, the machine builders and end users can plumb hydraulic lines so that they're always going to that fixture, because it's never coming out of the machine. But once we start looking at hydraulics needed for quick clamps or hydraulic clamps, some machine builders build those pathways within the table of the machine. If we have access and capability of doing that, in some cases we can build that interface into the base plate that the Unilock system would be mounted into. That then allows you to gain that production capacity, because now you have a hydraulic style fixture in a 5-axis machine.
Very good, John. Thank you very much. I really appreciate you and the team at Big Kaiser for providing today's informative webinar. And really, for those of you that are attending, the objective here is that we put a resource in front of you that as you have questions or you have needs, it's unlikely that we can address all of those in a webinar, but we want to make sure you at least have a contact that you can reach out to. In this case, John and the folks over at Big Kaiser. In the spirit of continuous improvement, we would sure appreciate your feedback on today's webinar, as well as receiving recommendations for future webinar topics. And speaking of future webinars, as John mentioned in the middle of his presentation, on Tuesday, June 21st, we will be joined by FANUC America to learn about robotics and automation, taking all of what we saw today to the next level. Whether you're interested in material handling, machine tending, or integrating automation into other areas of your facility, this will certainly be an informative and eye-opening presentation. Thanks again for joining us today, and have a great afternoon. Goodbye, everybody.